Okay, in this video, we're going to try to go over a few things with graphs. So anytime that we've got a graph, we know that the manipulated variable goes on the x-axis and that the responding variable goes on the y-axis. And so as time changes in this particular graph, here we can see that as the time changes, we get a change in the displacement. Now, displacement is a vector, and we can see that on this graph that our displacement is steadily increasing in the positive direction as time goes on. This is a straight line, and so we could calculate the slope of this line, and the slope is going to be equal to y2 minus y1 over x2 minus x1. So anytime that we're actually calculating the slope of a line, our general approach for that should be to not use the points that they supply us, but instead pick points on the line. So I would maybe pick, you can't see that, I would maybe pick this point. And this point would be ones that I would like, because they're kind of easy to read on the graph. This is going to be 2.5 seconds. That's my x1. And then my y1 is going to be at 20.0 meters, right? So we can see that is intersecting here. This one is going to be at 7.5 seconds, and it's going to be at 60.0 meters. And this is a displacement, so they describe the direction, so it's going west. Now, to calculate the slope here, I would take my y2, which is 60.0 meters, minus my y1, which is 20.0 meters, and then I would divide it by my x2, which is 7.5 seconds, minus 2.5 seconds. And I'm going to get 40.0 meters going west divided by 5.0 seconds. This will be 8.0 meters per second. And if we pay attention to those units, we can see that this is a velocity, right? And so in this case, we're calculating a velocity because what this is we've got the change in displacement over the change in time, right? So that our change in displacement here is these values, and our change in time is here. And by paying attention to what we've been given, by paying attention to the units that we've got and what they stand for, we could see that the slope of this particular graph is going to give us speed. Now later on, we're going to get a speed versus time graph. And if we were to do a slope for this graph here, so it's still going to be y2 minus y1 divided by x2 minus x1. But in this case, if I picked this spot, let's say here, this is going to be 1.5 seconds and 7.5 meters per second. And this is going to be, here will be 5.5 seconds, and it's at what looks like halfway through here, so 27.5 meters per second. Now, if I filled in this to find the slope on this graph, I'm going to get my 27.5 meters per second minus my 7.5 meters per second divided by 5.5 seconds minus 1.5 seconds. And so I'm going to get 20 meters per second, I guess 20.0, sorry, 20.0 meters per second divided by 4.0 seconds. And in this case, what I've got is I've got a velocity. So this is my velocity divided by time. And so what I'm actually calculating here is my acceleration, because acceleration is the change in velocity over the change in time. And so the slope of this graph gives us the acceleration. Now, if I took my, if I wanted to find the area or the distance that was traveled, the distance is on this is going to be, so if we had speed equals distance divided by time, if I wanted to isolate for distance, it's speed times time. And so this is going to be the time times the speed. Now the speed needs to be an average speed, but the distance or the displacement on this, because this is displacement and it's a vector, this is going to be equal to the area here. And so you can see it's the speed times the time. The area that's under this graph is going to be the distance. And so our distance is going to be that average speed. So if I wanted to calculate the distance for that triangle so that this object traveled in the first 6 seconds, it'll be the average speed. So it'll be 30.0 meters per second minus 0.0 meters per second, because that's what it started at. But I need to divide that by 2, right? Because that's going to give us this triangular shape, and it's the average speed. So it's this average speed times the time of 6.0 seconds, 6.00 seconds. So I'm going to get 30 divided by 2 times 6, and this gives me 90 meters. So the object has traveled 90 meters in that first 6 seconds. And then in this next 2 seconds, from 6 seconds to 8 seconds, the area under that, because it's a rectangle, is length times width. So it's going to be the 30.0 meters per second times 2 seconds. So that's going to be 60 meters. And if I wanted to know how much it traveled in total, I need to add my 60 meters and my 90 meters. And so the total distance is d1 plus d2 is going to be equal to 90 meters plus 60 meters is 150 meters traveled. Now, that works because that's a speed versus time graph. Whereas if I wanted to know the displacement on this graph, which is a displacement versus time graph, I'm reading off of the y-axis. So those are calculations related to both distance or displacement time graphs and velocity times graph or speed times time graph. For the general shape, if it is a displacement as a function of time, if it's a uniform motion, it's going to be a straight line. In this case, it's accelerating in the positive direction. If it was decreasing, that means it's moving in the opposite direction, and it's still a straight line, so it is still constant speed. If it was a horizontal straight line, then the displacement hasn't changed over time, and it's just stopped. So here is positive speed, or I guess positive velocity, because this is a displacement. It's moving in the positive direction. Then it stopped. And then it's moving in the negative direction, so it's negative displacement. So being able to read a displacement time graph and be able to see, oh, it's going forward in the positive direction, or it's stopped, or it's moving back in the negative direction, the negative displacement, is important. If you have a displacement time graph and you instead had a curved line, that means that this is accelerating. This is acceleration, and in this case it's in the positive direction, because you can see that the slope of this line is changing, right? So it's speeding up because that slope keeps changing. Whereas if we have a velocity time graph, here this is accelerating in the positive direction. Then in this next segment here, it's in this segment, instead, what this is doing is this is constant speed. You can see it's going to continue going at 10 meters per second. Here, it accelerates again. Down here, it's again at a constant speed, but in this case, constant speed of 0. And in this area, you can see that it is got a straight line on a velocity time graph. This is negative acceleration. So it's speeding up in the negative direction. Or I guess in this case, it's slowing down, but it's negative acceleration. Being able to read a graph and know what's happening during that graph is really important. And you really need to pay attention to, is it a velocity graph, a displacement graph, or they have two very different kinds of ways of dealing with them.